Different types of binaries, drivers, DLL and executable. So executable we have created. DLL we have not created, but we'll see what it is. Drivers are also pretty similar to DLL and exe, it's just that it's a native binary which loads in the kernel. All these files are portable executable PE. They are PE files. PE files are the files which can execute code in Windows. So the loader or the operating system understand the PE file. It can execute the PE file. PE files, all the malwares, all the code, all the softwares, all the good stuffs as well as bad stuff is in PE format. PE has that MZ signature. Whenever we dump a PE file, we will see that signature. So we'll do it shortly. Now, what is the difference between exe and DLL? Exe is a program's main executable. Exe we can use to create a process like Hello World we have done. DLL has a slightly different purpose. DLL are modules, different modules loaded into that process to achieve certain functionality. For example, printf is implemented inside the CRT-DLL. Create file is called from kernel32.dll, and a lot of functions are exported from ntdll. So they are DLLs. So why they are DLLs? Because they are DLL files loaded into different applications, but there is only one copy of that DLL inside the memory. So let's see that use case of DLL. Again, we are drawing our regular process address space. So this is the process address space. We have the user mode and kernel mode. This is user mode and this is kernel mode. We have the RAM here. This is our RAM. We have a 1 GB RAM. 1 GB RAM. We don't have too much RAM, so it's just 1 GB. We have the CPU here, which does the address translation, and we have the page table. Remember the page table? We have the page table inside the RAM. Suppose the page table is for this particular process. Now there are other processes right here. These are the other processes. I'm drawing it a little small. Doesn't mean that they are small. They are of equal size. They also has the user and kernel. Kernel is same for all these processes. The kernel is the same. So this is also same kernel. Now all these programs has a lot of common DLLs like ntdll, kernel32.dll, then user32.dll. Lot of such common DLLs are there, GDI32, so on and so forth. These DLLs are inside the disk right now, so they are in the disk. One of this process is mapping that DLL. Let me draw that here. There is a mapping of, say, ntdll into this particular process. ntdll is mapped here. Now there is a corresponding page table entry here for that ntdll. So there is a corresponding page table entry. Because of that particular page table entry, we have a corresponding entry in the RAM. This is the ntdll sitting in the RAM. ntdll. Now most of the code ntdll are executable, kernel32, user32, GDI32, all these DLLs, hardly people write into them. They are mostly read-only code. Of course, we write into the global variable, so we'll get to that later. We are talking about the code. Most of the part is code, which are read-only. There is no point having multiple copies of the same stuff inside the RAM. What we do is, we just map, so the ntdll must be loaded into all the application, or kernel32 for that matter. Kernel base, all this DLL has to be in all the processes loaded. What it does is all the page table entries, so this process has a page table entry, this process has a page table entry, all this process has different page table entries, but all of them points to this particular memory. this particular location inside the RAM. Just like in the case of kernel, they are common mapping for all the processes, which means that there will be only one copy of NTDLL inside the RAM. And that is the main purpose of DLL. There are other uses, minor uses, but main purpose is to avoid duplication of code inside the RAM and save memory. They are called shared object in Linux because of the same reason. So that is the concept of DLL and executable. Driver is very similar to executable, but they are loaded in the kernel. They are very similar to executable, so they have a main and stuff like that. We will see one driver. Most of the exercise we will be doing in one single driver. Now services. Services are just like any other application. Now before moving to the services, I would like to show you the DLL inside the debugger. We have seen to list down all the binaries loaded into a process using the lm command. This is the lm command. Winlogon is a exe file. We are in the context of Winlogon. So this is the same kernel debugger we were looking at before. In this case, once you switch into the context of a user application, kernel and user is pretty similar. Now this is a DLL. This is a DLL which is loaded into the Winlogon process. This is our kernel 32. We will have NTDLL here. Now this NT is part of the kernel. So this is the kernel address you are seeing here. And these are unloaded drivers. To see the drivers, load at the driver files, you need to switch it to the system context. Before that, I would like to show you the signature of a PE file, DC, then the start address of the binary. This is the start address of the binary. We have discussed all these things in detail before. So all I'm going to do is a DC. All the PE executables start with MZ. This is the short name of a Microsoft employee who was working on this particular area. This is his initials actually. This is the signature of a portable executable. This is the signature we normally search for finding portable executable files. That is what I wanted to show you. So next is services. Services are just like any other application. It's just that services run before any user login. These are in Task Manager. Now, if you go to Task Manager in the tab, you can see all the services right here. Some of the services are stopped, some of them are running. All these processes, so they are just processes. If you right click, go to details, we will see the corresponding process. So this is a process associated with that service. This process is very similar like the process we have created, the Hello World application. It is no different. It's just that they run in the context of a different user other than the logged on user. Remember, when we get into a system, we type the username and password. The system generates a token, the primary access token. That is the default token which is there with all the processes. On the other hand, these applications run before the logon. Some of them are part of kernel. Some of them implement Windows API, so we will see that, and so on and so forth. Only thing we need to know is that they start very early in the system startup before logon, and they are very similar to normal processes. So structured exception handling, so that is what we're going to discuss next. PEB and TEB we have seen already, so they are user mode data structures. So user mode, like I already mentioned, it is always dealing with committed bytes. So committed bytes is the dump. That is what we're going to focus on. Committed bytes are the bytes which you can touch. When you do an malloc, when you do a heap alloc, virtual alloc, what you get is committed bytes. Virtual alloc, provided you are passing the mem_commit flag. But some of the command output information is not really coming from this committed bytes. When you take the dump with /ma, the debugger makes some kernel calls, the kernel API calls to collect that information. Bang handle is an example. Bang runaway, bang address. Bang handle we have seen. Bang runaway we will see. And bang address also we have seen, and we'll see more of this later. So in short, this is the information we will be dealing with in the user mode. The process commit bytes, which is the dump, along with some additional information which is collected from the kernel for debugging purposes.